All right, so we are on to probably the hardest question in this chapter. And it's a situation where we do not know the initial velocity or the time. So if you run into one of these situations, you might want to look back in this part of your packet for that. So go ahead, put a star on there. This is what we do when we have no initial velocity or time. All right, so this is page 8 of the packet, right at the bottom, the place kicker. So let me read it to you. A place kicker must kick a football from a point 36 meters, about 39 yards, from the goalpost, and the ball must clear the crossbar, which is 3.05 meters high. When kicked, the ball leaves the ground at an angle of 49 degrees to the horizontal. What is the minimum speed needed to clear the crossbar? Okay. So in order to clear that crossbar, it's going to start here, and I'm going to choose that as my origin. So x equals 0, y equals 0 there. And 36 meters over in the x, 3.05 meters high in the y. So I'm going to go ahead, fill that in. This is a 2D motion problem, projectile motion, angled launch. Even though I don't know what V0 is, I still resolve it into those components and plug it into my list of variables. Now, why is this one such a difficult question? Because in each side I have two unknowns, time and initial velocity. And so it's a lot like those simultaneous questions we solved before, where we might not know two things, maybe like x and t. But when we don't know V0, the algebra just gets a little uglier. And so our pattern is going to be this over here. We're going to solve for t in the x direction. We're then going to substitute into the y direction, and then we're going to use something called solver. So I'm going to teach you how to use solver today on your calculator. All right, so let's do our first step, which is solve for t in the x direction. So here I am, I'm solving for t. The initial position was 0. And so I'm going to divide this v0 x over. So I have 36, well, I'll do it more with the variables, so it'll look a lot like yours when you try it. So I have x divided by v0 cosine theta equals t. All right, now what I'm going to do is I'm going to substitute this into the y direction. Okay, so in the y direction, I want to limit myself to these same two unknowns, v0 and t. v0 and t. So I want to get rid of vy. Okay, so that would be equation number 2. So I have y equals y0 plus v0 yt plus 1/2 ayt squared. Now, I'm going to take all of this and I'm going to substitute it in for t. All right, so here we go. So I have y equals y0 plus, and I'll substitute in here. So I have v0 sine of theta times x divided by v0 cosine of theta plus 1/2 times ay times x divided by v0 cosine theta squared. Now, a couple things that happen for us here that are kind of nice. One, in this middle term here, I see I have a v0 and a v0. One on top, one on the bottom, so they cancel. And if I'm pretty sly, I can see I have a sine over a cosine, and sine over cosine is, yes, tangent. So what this then becomes is this then becomes y equals y0 plus x times the tangent of theta plus 1/2 ay times x divided by v0 cosine of theta quantity squared. So at this point, you have to solve for this v0 that's hidden inside a square, inside a term with other stuff on its side. So there's a lot of algebra steps to do that. Can you do those? Yes, by all means, if that's how you feel comfortable solving it. I'm going to go ahead and I'm going to use solver. Now, depending on your calculator, depends on which form you are going to use. So I'm going to show us both forms here, but I want to get this set up first. Okay. So in order to use the older version of the calculator, I need to have everything on one side so it's 0 equals. So let's go ahead, crossing out that 0, and move this y over to the other side. So now I have 0 is equal to negative 3.05 plus x, which was 36, times the tangent of 49, plus 1/2 times negative 9.8 times 36 divided by v0, which I'm looking for, cosine of 49, quantity squared. Okay. Now I want to just add one little bit here, just so we remember it when we go ahead and type this in. See these blue parentheses here? Those blue parentheses make sure that all of that stuff is dividing underneath the 36. It's not like 36 divided by V0 and then multiplied by cosine of 49. That V0 cosine of 49 is grouped together in the denominator. So we need to remember, when I get to the end here, I should be doing 1, 2, 3 parentheses at the end. That's kind of the trick there. If you had the newer version of the calculator, this is going to look pretty similar. You can do it this way, or you can leave that 3.05 on the other side. So you would have something like 3.05 equals the 36 tangent of 49 plus 1/2 times negative 9.8 times 36 divided by V0 cosine 49 quantity squared. And again, you still need to remember that nice blue set of parentheses there. So again, let's hop over to our calculators. I'm going to show you both of these, so just you can fast forward through whichever one you don't want, and then I'll come back and give us the answer. All right, before we get started on this, make sure you have your mode set to degree mode, because we're going to be using tangent and cosine in degree. So to use Solver to solve this for us, what we want to do is we want to go to Math, go all the way to the bottom by just pressing up. You'll see Solver, that's the one we want, and just press up, or it might just be cleared already. So you want to get it something so it says 0 equals. Now you're going to type in your equation. So I have negative 3.05 plus, what was it, 36 times the tangent of 49 plus 0.5 times negative 9.8 times, and now I got to do that big squared thing. So it's got to be open parenthesis for my square. I got 36 divided by, now I got to open another parenthesis on the bottom. So my variable is x times the cosine of 49 down here. Close the parenthesis for the 49, close the parenthesis for the denominator, and close the parenthesis for the square. So I need those 3 parentheses there. So make sure yours looks like this, and then hit enter. Here we'll put in a guess. This is whatever x was stored as before. 15 sounds actually like a pretty reasonable guess. So let's go ahead and use that. So how we have to do this is, while we're hovered over this, we hit alpha and solve. And what this will do is it'll find the closest solution to this equation from 15. So it looks next to 15 until it finds the closest one, in this case 19.6. All right, let's head over to the other calculator now. So now we're on the color, the newer version of this calculator. So first thing we want to make sure we do here is we go into mode and make sure we are on degree mode, since we're going to be doing that. Then we go to Math, and we go all the way to the bottom to Solver. Now Solver is going to come up something like this. So we have equation 1 equals equation 2, meaning what's the left side of the equation and what's the right side of the equation. So on the left side of the equation I had 3.05, and then on the right side of the equation I had 36 times the tangent of 49 minus, oh, I guess we'll say plus, 0.5 times negative 9.8. And then I have to open up some parentheses here. So this is going to be the big square number. So I open up the parenthesis and I have, what, 36 divided by, now I need another parenthesis for the stuff on the bottom, my variable times the cosine of 49. And then I'm going to close the parenthesis on the 49, close the parenthesis on the denominator here, and I got to close the parenthesis for my square and then hit square. After I'm done with that, I can hit enter or click the OK, that's fine. And then we just got to put in a guess. So I'm going to put in 15 here. It's roughly where it's going to be. After I do that, I have to hit alpha solve, and it will then go ahead and find the closest solution to this equation from 15. So I hit alpha solve, and it pops up 19.6. All right, let's head back to the board. All right, how cool is Solver? So Solver is an amazing tool on our calculators. And so either with the old version or with the new version, we got the same answer of 19.6 meters per second. So